Curious Kid Cast, here we go. Questions poppin', minds will blow. Big ideas, they're taking flight. Let's explore, feel the light. Why, what, where, and how? Big answers, we'll find them now. Curious minds, the world will comb. Ask away, let's bring it home.
Hey there, Curious Kids! Andy here, coming at you with another mind-boggling episode of the Curious Kid Cast, where we answer the wackiest questions in the universe. Today, I've got a bonkers question that might make your brain do backflips. Have you ever wondered what would happen if every single person on Earth, yes, all 8 billion of us, jumped up and down at the exact same time? Would we knock Earth off course? Would we cause a mega earthquake? Or would it just be a big old funny jump? I know what you're thinking. Andy, that's the silliest thing I've ever heard. But guess what? Scientists have actually thought about this too. So put on your thinking caps because we're about to do some serious, but totally fun science. First things first, let's talk about what happens when you jump. When you want to jump, you bend your knees and push down on the ground super hard with your legs. And guess what? The ground actually pushes back up on you. It's like you're on an invisible trampoline. That push from the ground is what sends you flying up in the air. This is something scientists call Newton's third law. I like to call it the you push me, I push you rule. Basically, it says that for every push, there's an equal pushback in the opposite direction. Every action has an equal and opposite reaction. It's like when you push your little brother, he pushes you back, though sometimes a little harder than he should. So if all 8 billion people on Earth jumped at the same time, that's a whole lot of pushing down on the Earth all at once. But what would all that pushing actually do? To figure that out, we need to think about size. Like, how big and heavy are all the people compared to the Earth? It's kind of like comparing a flea to an elephant. All those people together, all 8 billion of us, weigh something like 496 billion kilograms. That's like a bazillion candy bars, or about 1 million blue whales. But now think about the Earth. Our planet is mind-blowingly gigantic and heavy. How heavy? Get this. It weighs something like a 5 with 24 zeros after it kilograms. That's a 5 followed by 24 zeros. That's so many zeros I'd run out of breath trying to say the whole number. Let me put it another way. Imagine a teeny tiny ladybug trying to push a giant school bus. That ladybug can push as hard as it wants, but that bus isn't going to move even a teensy bit. We're like those little ladybugs compared to the giant Earth bus. So even though there are billions of us jumping, the Earth is so incredibly massive that our jump just wouldn't be strong enough to move it much at all. It would be like trying to move a mountain with your pinky finger, or trying to lift your school with a piece of spaghetti. Let's talk about momentum too. Momentum is basically how much oomph something has when it's moving. Like if you roll a bowling ball down a lane, it has a lot of momentum because it's heavy and going fast. But if you toss a little bouncy ball, it doesn't have as much oomph. Imagine everyone on Earth jumps up at the same time. Let's say we all jump about as fast as a quick walk, like 3 meters per second. Now, if you add up all that oomph, all that upward momentum from every single person, it would be a lot, right? But then we have to think about the Earth's own momentum. Our planet is constantly moving. It spins around like a top and also zooms around the sun. And because the Earth is so incredibly heavy, its momentum is absolutely enormous. Way, way bigger than our jump. It would be such a tiny, tiny change that we wouldn't even be able to measure it. It would be like a little ant trying to push a giant boulder that's already rolling down a hill, or like trying to stop a runaway train by blowing on it. Not gonna happen, friends. Okay, so the Earth isn't going anywhere, but what about earthquakes? Could all that landing at once make the ground shake? Real earthquakes happen when these giant pieces of the Earth's crust, called tectonic plates, bump into each other and release a ton of energy. It's kind of like when two cars crash into each other, but on a much bigger scale. Those plates are enormous, and the energy they release is just mind-blowing. Our jump, even with all those people, wouldn't be enough to make those plates move, not even close. The energy from all of us landing wouldn't even compare to the massive power of an earthquake. It would be like comparing the pop of a tiny bubble to a giant explosion. Or like comparing a mouse squeak to a rock concert. But hey, I think I read somewhere that scientists might be able to feel our jump with their special instruments. Scientists have these super sensitive machines called seismographs. They can pick up even the tiniest vibrations in the ground, like a dog can hear a whistle that humans can't. So even though we wouldn't cause a real earthquake, they might still be able to see our jump on their fancy machines if, and this is a really big if, everyone could jump and land at the exact same time in the exact same spot. Picture everyone crammed into an area the size of a city and all jumping together. That's a lot of people. It would be like a giant synchronized stomp, and that might just be enough for the seismographs to pick up a little wiggle. But it's still not a real earthquake though, right? Nope. Real earthquakes are way, way stronger. It would be like the difference between someone tapping on your shoulder and a giant bear hug, or like comparing a whisper to the loudest burp in the world. Okay, so no moving the earth, no giant earthquakes. But what about the air? When we jump, we push air out of the way, right? Could our giant jump create a huge gust of wind or something? Well, think about what the air is like all around us. It's always moving, right? We have wind, clouds, all sorts of things happening up there. Compared to all that, the air we push down when we jump is pretty tiny. So even if billions of people jumped at once, it wouldn't really change the air much at all. It would be more like a little puff of air compared to a hurricane, or like blowing out a birthday candle versus a tornado. Not even close. So even if billions of people jumped at once, it wouldn't really change the air much at all. It would be more like a little puff of air compared to a hurricane, or like blowing out a birthday candle versus a tornado. Not even close. So even though it's a super fun idea, our global jump wouldn't have that big of an impact on the Earth. It's kind of funny though, because people have actually thought about this idea before. Have you ever heard of World Jump Day? World Jump Day was this big internet joke a while back where everyone was supposed to jump at the same time to try and change the Earth's orbit. Of course, as we've talked about today, that's just not possible. Though it would have been pretty hilarious to see everyone hopping around like popcorn in a pan. But what if, just for fun, we imagine that every single person could somehow get together in one place, like a giant city, and jump at the same time? 8 billion people all jumping in the same spot. That's a sight I'd love to see. It would be like the world's biggest trampoline party. But even if we were all squished together like sardines in a can and jumped all at once, it still wouldn't have a huge impact on the Earth as a whole. The Earth is just that massive. It would feel pretty amazing there on the ground like a super stomp, but the Earth would barely notice. It would be like an elephant not noticing a flea doing jumping jacks on its back. Wow. It really puts things in perspective, doesn't it? Our little jump wouldn't do much, but there are things we do every day that have a much bigger impact on the Earth, good and bad. All right, so to sum things up, our giant global jump, while super fun to imagine, wouldn't cause any giant earthquakes, launch the Earth into space, or create mega windstorms. It all comes down to the fact that the Earth is just so incredibly, unbelievably big compared to all of us. Now it's time for our Curious KidCast quiz. Get your thinking caps on, and don't worry if you don't know the answers right away. I'll give you some time to think about each question. Question 1. What is Newton's third law about? The answer is, for every action, there's an equal and opposite reaction, or as I like to call it, the you push me, I push you rule. Question 2. How many zeros are there in the Earth's weight when written in kilograms? The answer is 24 zeros. That's a 5, followed by 24 zeros. That's so many zeros, you could make a necklace out of them. Question 3. What special scientific instrument might be able to detect everyone jumping at once? The answer is a seismograph. These super sensitive machines can detect tiny vibrations in the Earth. They're like the Earth's very own tickle detectors. So even though we can't move the Earth with our jump, it's pretty awesome to think about all the other amazing things we can do when we all work together. That's it for today's episode of the Curious KidCast. If you enjoyed this brain-bending adventure, don't forget to share it with your friends and subscribe so you never miss an episode. And hey, if you have any wild and wacky questions you'd like answered, drop them in an email to questions@curiouskidcast.com or visit our website at curiouskidcast.com. This is Andy signing off from the Curious Kidcast, where no question is too silly and curiosity rules. Stay curious, kids, and keep on asking those awesome questions.